Wood is a fabulous building material that has kind of been pushed out in the larger buildings we're building today by the steel and concrete strategy.
This is Oregon Senator Jeff Merkley.
It's where I come from, by the way. I come from a little tiny timber town, Myrtle Creek.
And there's a really good reason this senator is talking to me so effusively about building high-rises out of timber instead of steel. But to get to that reason, we need to start with actual trees. And with fire.
Massive wildfires in Southern California.
Wildfire burning in southern Utah.
The largest fires in Napa, Sonoma, and Mendocino counties.
Recently, forest fires spread to unexpected, usually wet places like Oregon and Washington.
We have vast areas in this country where our success at putting out wildfires for the last 100 years has led to overstocked forests.
Steve Marshall is in charge of the U.S. Forest Service's Wood Innovations Program, which is trying to find creative solutions to the overcrowding of forests. And one of his solutions might be coming to a skyline near you.
We'd heard a little bit about what was going on in Europe with cross-laminated timber. Seemed kind of intriguing.
England, Italy, and Scandinavia have all taken on CLT projects in the last 2 decades.
There are hundreds of buildings made out of CLT in London right now.
Humans have built houses out of wood for millennia, but when we aspired to go higher, we started building with steel. Marshall thinks cross-laminated timber could change that. So I headed to a place known for its trees.
I tell people that if the economy in the United States is sneezing, the lumber industry gets pneumonia almost immediately.
This is Valerie Johnson, co-owner of D.R. Johnson Lumber Company.
My parents came down to this area and built a little sawmill, and that was their start in 1951. A lot of things are different than what they had in those days, including the opportunity to make more engineered wood products like CLTs.
D.R. Johnson is one of the first lumber mills in the United States to start making cross-laminated timber, or CLT. It's made by fusing together pieces of solid wood.
We've really done a lot of extensive testing in collaboration with some other terrific organizations.
Turns out, wood is stronger than you think.
Our panels now are tested for 2-hour fire test, and we're only required to go 90 minutes. And there's a series of seismic testing with the right connectors performed wonderfully, very resilient, can return to the original state of the structure and be inhabitable rather than needing to be torn down and rebuilt.
But how does a piece of ordinary wood get made into CLT?
Making CLT panels is really quite simple. It's not rocket science at all. We take regular kiln-dried dimensional lumber. We have a finger joiner to make lengths of lumber longer if we have a longer panel. We glue up the long length of the panel, and then our perpendicular layer of shorter pieces go on. So we make 3-layer, 5-layer, and 7-layer panels depending on the amount of strength that the panel must carry. And it goes into a press, and the press comes down and puts quite a lot of force, like 110 to 120 psi press on the panel. And once that's done, it's the finishing, the fabricating, the cutting, and the logistics of keeping track in the right order of all of those components. But actually making the panel is not very complicated.
And a lot of CLT is being used to construct buildings in Portland. There are a lot of reasons why CLT buildings work well in Portland. For one, the city is environmentally conscious, and CLT is great for the environment.
I actually have this theory. It's a bit of a stretch, but for instance, the building we're sitting in, carbon-12, has a lower carbon footprint than had we not built a building at all on the site.
This is Ben Kaiser. He's one of the architects in Portland constructing wooden high-rises.
The fabrication of steel is steel smelting and high heat, and that generates a huge carbon footprint, and same with concrete. Whereas when you build with wood, what's really interesting about that is that it sequesters carbon.
Basically, the carbon is trapped in the wooden beam rather than released into the atmosphere. Then more trees can be planted in its place that sequester more carbon, and so on and so on. But that's not all.
Almost equally important is the visual, the aesthetic of it when you're done. They say there's a lot of studies too about living in a wood atmosphere, kind of with wood around you. So they say it's actually a healthier environment to live in.
It isn't 100% perfect though.
Never said cheaper. In all honesty, this building did cost more than had we done it in concrete, because this is really the first of its kind in the United States. And as you can imagine, being first and pioneering, you're going to pay a premium to figure out all the kinks.
Speaking of pricing, there's one aspect of this building we haven't mentioned yet.
That ceiling right here that you're looking at is the panel that came right off the truck from Canada.
That's right. Kaiser's firm got their CLT from Canada. When I told Oregon Senator Jeff Merkley that, he wasn't pleased.
Yeah, that hurts.
The Canadian market, says Merkley, is huge competition for American CLT companies. The University of Massachusetts' new design building, for example, is built with Canadian CLT.
They have advantages our companies don't that make their trees less expensive.
CLT production in Canada gets money from the Canadian government. So I asked Senator Merkley if the U.S. government would ever subsidize the American timber industry.
Well, possibly grants to help with these initial buildings, but for this to really thrive, I think it's going to have to prove itself in the marketplace.
Ultimately, the reason the government is funding this is to provide jobs, but also to solve the problem of thinning America's forests. And if American architects are buying Canadian CLT panels, that's not really going to happen.
We had fires raging from Montana, Idaho, Washington State, Oregon, California, and driving technologies that can help create a market for thinning forests and getting a steady supply of saw logs while increasing the number of jobs. That sounds like a pretty good deal.